Thank you so much, Pat, for that introduction. And gosh, it feels so great to finally be here, especially after these past crazy couple of years that we had with COVID, right? Well, I would like to start this presentation with one quote from the European Voice of Directors in 2020. It is no longer a question of whether an organization will be hacked. It is simply a question of when. Cybercrime is a serious threat, regardless of your industry vertical or organization size. Web application attacks are consistently rising, and they have more than doubled since 2019. They accounted for nearly 25% of all the breaches in 2021. Think about that, a quarter of all the breaches. This is according to the Data Breach Investigations report from Verizon. The World Economic Forum has also stated that the global digital dependency of our societies will only continue to intensify cyber threats. Cybersecurity failures are ranked among the top 10 risks that have worsened most from the COVID-19 pandemic. Traditional security approaches no longer work for agile teams. Innovating first and protecting second is no longer feasible. I have some good news and bad news for you. On the bright side, cybersecurity is increasingly a priority for leaders. In the State of DevSecOps report, a solid majority of respondents declared that on their organizations, application security is a C-suite performance measurement. Unfortunately, traditional security approaches still address security too late, and they slow down teams. Nearly half of the respondents stated that their teams sometimes or often skip security processes in order to meet deadlines. In the State of Developer-Driven Security survey from this year, both developers and engineering managers state that writing secure code is really hard, in part due to a lack of secure coding skills in their teams. A lack of time, planning, and prioritization are among the top barriers. I've experienced these issues firsthand in some teams that I've worked with, and they struggled with very similar things. One particular experience that I can think of, I think it's a perfect example, so I would like to tell you this story. When two major companies merged a few years ago, my team and I set out to connect their digital channels with a single sign-on. Implementing and integrating an off-the-shelf single sign-on solution was just taking too long. And with the launch date for their rebranded site rapidly approaching, they needed a quick fix. There was a solution that was proposed by some architects, and we had about 4 months to implement it and ship it to users. Full disclosure here, I am not a security expert, but even for me, as a developer, it felt pretty clear that security and privacy were clear requirements. If we focused on functionality alone, we would be able to implement the solution and meet the deadline. However, we identified some major vulnerabilities in its design, and mitigating those would take more time. But we tried our best to explain the security risks we found to the business, and we actually came up like this. It wasn't easy. Trying to renegotiate the deadline just made tensions worse in an already stressed business. There was another problem. As far as the business was concerned, their systems were actually safe and secure. There was no reason for them why this solution had to be any different by default. But there were signs that pointed the other way. Early on, we discovered, for example, that their developer teams and security teams had very little collaboration with each other. We also noticed that monitoring in the applications was minimal. On top of that, the security department was understaffed, and they had no significant influence on the company digital strategy. In the end, despite our best efforts, the business urgency won. My team and we had to run against the clock and implement a solution we knew was risky and vulnerable. Now, if you can relate to me and my team in this story, at least a little bit, let me tell you, you are not alone. The most effective way we have to protect our users and our companies is to break the barriers that hinder collaboration between developers and security experts. We need those skills in our teams if we want to implement features securely from the start. It is also important to help our business decision makers to make better informed choices on the security of our products. And the way we can do that is by making the risks more real. Here, when it comes to cybersecurity in an organization, it really needs to be integrated across processes, technology, and people. But even if your organization isn't there yet, you can do something. You can change your own team's culture. And here's my key advice to you today. Discover the real and active threats in your products. Let me go back to my story to explain a little bit more what I mean by this and why I think it is so important. The solution we had to implement implied making a few changes to the existing systems in the organizations. First, we would keep the authentication, authorization, and session management mechanisms on the backends, and we would make just a few tweaks to them. Then we would build a separate component to route authentication requests. Finally, we would implement invisible pixels in the front ends so that we could transfer session information from one domain to the other. Through workshops with developers, architects, we learn more about the existing digital channels and the login flows. We discovered, for example, that we had a combination of both monolithic and service-oriented architectures, and that these applications were running on separate data centers managed by each of the former two companies. The monolith in this case was using outdated and vulnerable encryption algorithms because it was quite old and hadn't had much love, really. We also discovered that we had some personal information stored in plain text in the session cookies. Now, I mentioned that monitoring capabilities were limited. User complaints were the main source for finding issues. For example, a user call to a call center would be the main alerting mechanisms to realize the whole site was down. True story. We also spoke with the security department, and from them we learned more about the security measures across the organization. mostly at the data center and networking level. For application security, there was a web application firewall, or WAF, that was configured with really high thresholds to cover a wide range of applications. We later learned that there were some bot attacks that were being just mislabeled by the WAF because of these high thresholds as normal traffic, and they were operating undetected for a while. It was both interesting and frightening to discover the high number of fraud cases handled by the security department. But apart from a weak password policy, they weren't, aware of any data breaches. So users were often blamed for fraud cases, claiming they had been victimized by social engineering. As we progressed with the implementation, we also continued our discussions and our sessions with the security department, architects, and developers. And that all helped us enrich this diagram. And this brings me to the first tip I have for you today. Threat modeling is your go-to tool. There are great resources freely available on the internet to learn more about threat modeling, but I could really recommend one in particular, a guide to threat modeling for developers that is available on Martin Fowler's blog. The diagram I show you was a very simplified version of what you could get if you run a threat modeling session and answer at least the first question: what are you building? The tool is extremely powerful and effective in two main areas. The first one, discovering and prioritizing the threats in your products. And the second one, fostering collaboration between developers and security experts. What was most valuable about this diagram for us was that it gave us insight into what we were building, and it helped us find some of the actual existing weaknesses that were there, and we didn't know. It also helped us locate a security expert within the security department that was willing to work closely with developers. And from him, we learned tons about secure coding practices, secure concepts, threats, and even tools. He quickly became a key ally and an informal team member. Our situation was a bit tricky because, remember, our PO thought that there was nothing to worry about security, right? So we couldn't just take the vulnerabilities we had found and prioritize them and start working right away on them. We needed to find a strong argument that would persuade our PO that investing in mitigation and prevention in security was actually worth the effort. So with the knowledge we already had here, plus some evil brainstorming, we decided to focus on one particular attack vector, the authentication flow. You see, we had reasons to believe that some of these fraud cases were linked to attackers getting access to the credentials of the users through our own system. Especially because we knew there was a bunch of users that had very weak passwords that were easily guessable with a very common password cracking dictionary. But we also knew we had many vulnerability paths that could easily be exploited to do that. So we had this hypothesis, right? Now, we started thinking, how could we actually validate and maybe prove or disprove this hypothesis? So we went back to our technical diagram. And as part of our solution, we knew we were opening up REST endpoints on each of the backends, the existing backends, to allow for the login requests from the login router. Now, these endpoints would return a 200 response for any successful login, meaning any matching, credentials that were found. HTTP 400 response would be returned in case there was no matching login, so an unsuccessful login. There was no match for username, no match for password, or no match for both. So we knew this. Now, we also knew we had access to a log-based monitoring tool. And what we did was we built sufficient logs in our logging router to give us near real-time visibility, not only on the amount of requests that our logging router was processing, but also on the distribution of responses that we got from each of the backends. And when the solution went live, we started collecting metrics and data and logs, and we paid close attention to our dashboards. A few days in, we noticed the first strange behavior. Under normal operations, our dashboards would show a stable line of 200 over 400 responses over time, and what in the reference graph is seen as successful and failed requests. We were also monitoring the ratio of 400 over 200, and that value would be normally below 0.5%. This was our starting point. This was our baseline. What we noticed was that several days, and sometimes even many times a day, we would see an increase in the 400 error rates that was scaling even beyond the rate of successes. We also saw an increasing ratio of 400 over 200, spiking. So we knew we were into something. What we did then was we grabbed our security expert, and with his help, we started analyzing a little bit more this traffic. We noticed that these spikes of traffic that were generating 400 responses were all coming from a single IP address at a time, and there were other suspicious parameters as well, like the client browser. So we were able to conclude with the security department together that these spikes were actually being caused by bots and not by real users. We finally had proof that malicious users were trying to brute force our login, trying to get a hold of our user credentials through brute force. These results were undeniable. And here comes my second tip for you. Detecting malicious activity is a key part of building security. Typically, we monitor our products from the perspective of our target users, right? The ideal user, the one we are building this product for. However, thinking about the malicious user is equally important, and we need to monitor for that. The second question in a threat modeling exercise asks, what can go wrong? By answering that question, you will think about all the possible ways in which your products can and will be abused. Some of those findings will be easier to detect than the others, but you will need to experiment a little bit and be creative when it comes to detection. When it comes to brainstorming and evil brainstorming, you could use a tool that is called Stride. Stride is a very light framework where each one of the letters stands for a different security concept. So it's very useful not only to learn more about security concepts in general, but also it will help you and your teams brainstorm more effectively. But don't just stay there. This is a really good tool, but it's not enough. It doesn't cover everything. And remember that the key is to collaborate closer with our security experts. So run some workshops with them, get together with them, learn from them, and keep upgrading your tool set. Now, visibility and detection. They are vital components of building a security culture in your teams. They will give you powerful arguments that will help you convince business stakeholders that prevention and mitigation are worth the effort. So what did we do with the attacks that we discovered, right? First, we shared them with our PO. And we actually caught her reaction in camera. I want to show you. She was truly terrified, really. Now, the next step was we wanted to share these even to a broader audience. We had showcases every sprint where business stakeholders and technical stakeholders would, come there, and we would just share our progress and our achievements and our plans for the next sprints. We had also POs from other teams coming into these showcases every now and then. So we brought our findings there. And we again caught them in camera, so take a look at the reactions. The cat, isn't it beautiful? The surprise was real. The point is everybody was surprised in the room. And from that moment on, the state of the security of our applications became a topic, a regular topic of our showcase agenda. But it wasn't just another checkpoint to check there, and that was it, and we can forget. No. Initially, we worked together with our PO to determine, prioritize, and implement mitigation measures for the ongoing attacks. Of course, that was the prior number one. But then, once that was done, we adapted our team's ways of working to introduce security practices as part of our day-to-day tasks and our processes. As an example of what we did, we went back to our technical diagrams and we mapped more threats, and we went and prioritized them based on risk. We also produced attack trees for these threats. These attack trees are conceptual diagrams that shows how an asset or a target might be attacked. We then went and updated our definition of ready for development. And we included security-related acceptance criteria in our stories. So whenever we had a new story, we would go back to these attack trees and the threats and the diagrams, and we would think on what are the things that we need to build into this story so that we cover the security aspects or the possible vulnerabilities that we're opening up with this. We leveraged automation whenever possible, and we created metrics and logs and dashboards to increase our visibility and discover vulnerabilities and attacks, malicious activity early on. Our team was embracing this new culture, but we didn't want it to stop there. We found some knowledge-sharing spaces within the company, and we started teaching other developers what we had learned, what were the tools that worked for us, what didn't work, and what we were learning in general from all the results that we were having. It started with 15-minute snack time spaces where we would share this. But then pretty quickly, it grew and evolved. It got into a community, a strong community, with regular monthly talks and hacking exercises. Nowadays, this organization is running a very successful external bug bounty program. Other POs were asking their teams about security as well, because they were part of our showcases, right? So they started wondering, okay, if they found this, what do we have in our products? So that was also helpful, because it created a real need, a real sense of urgency. that just inspired people and gave people the space to learn. And this finally brings me to my third and last tip I have for you today. This is the most simple one, and it might sound obvious, but many teams and organizations actually underestimate it and seem to forget about it quite often. Share your knowledge. Sharing knowledge is at the core of any learning organization. And agile, DevOps, DevSecOps, they are all movements that are built on top of learning organizations. Building any culture is a never-ending journey, and this applies for any DevSec culture as well. But cyber criminals are getting more sophisticated every day, and our organizations and our teams need to adapt and continuously improve. All you need to do is to plant the seed. And if you're already part of an organization that values agility and continuous improvement, chances are that applying these 3 tips I gave to you today will help you and your teams build more secure products. And if your business is not convinced yet, just remember to discover the real and active threats in your products, because that can be your PO. That's all I have for you today. Thank you so much.